Hello people, in this video we are going to learn about Charles law. And Charles law, this is a law that describes the relationship between the volume of a gas and its temperature. And by the end of this video, one should be able to 1. State the Charles law, 2. Describe Charles law graphically and mathematically, 3. Solve numerical problems on Charles law. Let us start by stating Charles law. What is Charles law? Charles' law states that the volume of a given mass of a gas is directly proportional to its absolute temperature at a constant pressure. So that's how we state Charles' law. We can as well describe the law mathematically, whereby volume is directly proportional to what? To its absolute temperature. So if you want to remove the sign of proportionality and introduce an equal sign, we must introduce a constant. So it will be volume equals to K multiplied by temperature, whereby V stands for volume, K for constant, and T for the absolute temperature. So if you want to make K the subject, we'll divide this side by T and the other side by T. So V over T equals to constant. So from the law, when volume changes from V1 to V2, temperature will as well change from T1 to T2. So if you want to make the equation, it will be V1 over T1 equals to V2 over T2. So this is the general equation of what? Charles' law. And basically, that's how we can describe the law mathematically. We can as well describe it graphically. So a graphical representation of Charles' law is a graph of volume against temperature. So a graph of volume of a fixed mass of a gas against temperature is always a straight line. And this is how the graph looks like. We have the y-axis and we have the x-axis. So yeah, this is y-axis, and we have our x-axis. So as I had said earlier, a graph of Charles' law, it is a straight line. It's a straight line, and the line cuts the x-axis at negative 273 degrees Celsius. Remember, this is a graph of volume against temperature. Volume against temperature. Volume against temperature in degrees Celsius. So basically, that is how a graph of Charles' law should look like. Now let us try a numerical problem on Charles' law. So here is our practice question. A gas occupies 450 cubic centimeters at 27 degrees Celsius. What volume will the gas occupy at 177 degrees Celsius if its pressure remains constant? So from the Charles' law, V1 over T1 equals to V2 over T2. Now, since we have the temperature in degrees Celsius, we must convert the temperature now to absolute temperature. And how do we convert degrees Celsius to absolute temperature, that is in Kelvin? There is a video that I posted on how to convert degrees Celsius into Kelvin. You can check that out. So our temperature is now 27 degrees Celsius. So in converting 27 degrees Celsius, we add 273. So if you take 27 degrees Celsius plus 273, what will that be? That will be 300 Kelvin. So that is temperature 1. This is T1. And temperature 2, we have 177 degrees Celsius. So if we take 177 degrees Celsius plus 273, what shall we have? So we'll have 450 Kelvin. This is now temperature 2. Now from there, we can work that out. So our V1 here is 450 cubic centimeters over T1, which is 300 Kelvin, equals to our V2, which we don't have. We must find the volume, which is V2, over temperature 2, which is now 450 Kelvin. So for us to get the value of V2, we'll cross multiply, or maybe we make a V2 the subject by cross multiplying. So it will be 450 cubic centimeters multiplied by 450 Kelvin equals to V2 multiplied by 300 Kelvin. Right? Now from there, if you want to get V2, or if you want to make V2 the subject, we'll divide this side by 300 Kelvin and the other side by 300 Kelvin. So V2 will be 450 cubic centimeters multiplied by 450 Kelvin divided by 300 Kelvin. So Kelvin and Kelvin will cancel, the units will cancel. So V2 will now be 450 multiplied by 450 divided by 300. So if you key in that in your calculators, what you'll get is 675 cubic centimeters. So that is the new volume, or volume 2. Yeah, it's my hope that is well understood. Now, there is a practice question or an exercise that I'm giving out, so you can try that out and submit your response in the comment section below. Yeah, so that is the exercise. So you can try that out, and don't forget to put your answer in the comment section. It's my hope that you've enjoyed the class, and don't forget to like, to subscribe, and share the video. Until next time, bye bye.